This video is about tree data structure and the terminologies which are used with tree data structure. So first we'll consider the definition of tree. So tree is a collection of nodes. The collection can be empty. If not empty, then a tree consists of a specially designated node called the root node and 0 or more non-empty subtrees. Right? Each of whose roots are connected by a directed edge from root. This is diagrammatical representation of a generic tree. See, this tree is not empty. It contains a root node. This is a special node of the tree, root node. Right? And see, there are 10 subtrees here. There are 10 subtrees T1 to Tn, which are connected to root by a directed edge. In a tree data structure, every individual element is called as node. A node in a tree data structure stores the actual data of that particular element and linked to the next element in a hierarchical structure. In a tree data structure, it's actually a property of the tree. If we have n number of nodes, then we can have maximum of n minus 1 number of edges. This is an example of tree. So in a tree, actually we represent the nodes with the help of circles and edges with the help of lines. Right? So in this tree, we have 11 nodes and 10 edges. Now we'll consider the terminologies which are used with tree data structure. The first terminology that we are going to consider is root. So in a tree data structure, the first node is called as root node. The first node. So in this example, the first node is A. So this is called as root node. Right? In any tree, there must be only one root node. Next, about edge. In a tree data structure, the connecting link between any two nodes is called as edge. So in this example, there is a connecting link between the nodes A and C. So this is called as an edge. Now, parent. In a tree data structure, the node which has a branch from it to any other node is called a parent node. So the node which has a branch from it to any other node is called a parent node. So here this node is got a branch from it to the node B and as well as node C. So it's a parent of B and C. Now about the child node. In a tree data structure, the node which has a link from its parent node is called as child node. So here in this example, B is a node and it got a link from its parent node, which is A, right? So this is B is child of A, right? So in this example, B and C are children of A. And now about siblings nodes. So in a tree data structures, nodes which belong to same parent are called as siblings. So in this example, see nodes B and C, they belong to A, right? Same parent A. So these are called as siblings, right? B and C are siblings because they belong to same parent A. And similarly, G and H are said to be siblings because they belong to same parent C. Now, let's see which nodes are called as leaf nodes. So in a tree data structure, the node which does not have a child node is called as a leaf node, right? So leaf nodes are also called as external nodes, right? and external node is a node with no child, and leaf nodes is also called as terminal nodes, right? So in this example, these are nodes with no successors, so these are called as leaf nodes. And now we'll see which nodes are identified as internal nodes in tree data structure. Okay, so in a tree data structure, the node which has at least one child is called as internal node, right? Internal nodes are also called as non-terminal nodes. And that means nodes other than the leaf nodes are called as internal nodes, right? And root node is also said to be internal node if tree has more than one node. Right? So in this example, tree is having more than one node. So in this root is also said to be internal node here, right? Because tree got more than one nodes. And in this tree, A, B, C, E, and G are internal nodes. Now suppose tree got only one node, say A, right? So tree is having only one node now. So this is identified as root node, that's it, right? So the root node is also said to be internal node if tree has more than one node. Now let's consider what is degree. So in a tree data structure, the total number of children of a node is called as degree of that node, right? So in this example, A got two children, B and C. So the degree of this node is 2. D got three children, D, E, F. So the degree of this is 3, right? So I, no child, so degree is 0. Z, one child, so degree is 1, and so on, right? So there is another term which is called as degree of the tree. So what is degree of the tree? The highest degree of a node among all the nodes in a tree is called as degree of the tree. So here, node B got highest degree, which is 3. So the degree of this tree is 3. Now let's consider level. In a tree data structure, the root node is said to be at level 1. See here, this is root node and it is said to be at level 1. Right? And the children of the root node are at level 2. So the children of the root node are B and C. They are at level 2. And the children of the nodes which are at level 2 are considered to be at level 3. That means in a tree, right? In a tree, each step from top to down is considered as level, and level count always starts from 1 and incremented by 1 at each level, right? So now there is another term called height or depth of the tree. So what is height or depth of the tree? So height or depth of the tree is maximum level of any node in the tree, right? It's a maximum level of any node in the tree. So now what is the level of node A? Level of node A is 1 because it is at level 1. The level of node B is 2 because it is at level 2. C is also 2. The level of node D is 3. E is also 3 because all these are at level 3. So all the nodes level is 3. So what is height or depth of the tree? It's a maximum level of any node in the tree. So the maximum level of node D, E, F, G is 3. So that's why the height of this tree is 3. The height of this tree is 3. Our depth of the tree is 3. Now let's see what is path. In a tree data structure, the sequence of edges from one node to another node is called as path between that two nodes. So sequence of edges from one node to the other node is called as path between the two nodes. So there is, say in this example, so there is a path between two vertices A and J. So this path includes edge A to B, right? And then there is an edge from B to E. Then there is an edge from E to J. So this is a path from A to J. So it is a sequences of edges. See, there is an edge from A to B, then B to E, then E to J. So this path is leading us from vertex A to J, right? So this is a path. So next there is another term called length of path. So what is length of path? So length of path is total number of edges in that path, right? So in this example, see total number of edges in this path are, so the edge AP, then edge PE, and then edge EJ. So there are 3 edges in this path. So length of this path is 3. Length of the path from A to J is 3. Why? Because there are 3 edges in this path. So the length of the path from C to K. What is length of this path? It contains only 2 edges. One is C to J and G to K. So the length of this path from C to K is 2. And now let's see what is subtree. So subtree of a node consists of a child node and all its descendants. So in this example, we'll see what are the subtrees of this node A, right? So subtree of node A now contains its child node B and all its descendant nodes. This is one subtree. There is another subtree for node A, which contains the child node C and all its descendants. This is another subtree. There are 2 subtrees for node A in this example. A subtree is itself a tree, right? And in a tree, a node may have any number of subtrees. Thank you for watching this video.